All right, let's have a look at our homework that we had over the weekend, page 51. We did number 1 already. Let's take a look at number 2. It says the 1968 Corvette took 6.2 seconds to accelerate, 160 to 220. Find its acceleration. Anything that we should look at on this, draw attention to, circle in red? Sorry, I didn't even hear what he said. Kilometers an hour. Okay. I heard it from you. Didn't hear it from Ethan because I was ignoring what he said. So kilometers per hour is good, or at least it's good that we circle that because we want to convert that to meters per second. Travel 220 meters. That's good. Can leave it there. Hey, by the way, could we leave that in kilometers per hour and convert that to kilometers? Clearly, we got to be in the same units, right? Could we, though, go the other way around and go kilometers there? Not anymore. Okay, back when we were doing our group A equation, that was our V is equal to delta D over delta T. We could really be in whatever units we wanted. The standard was meters, seconds, in meters per second, but we could be in kilometers per hour, and we were fairly often, right? Or meters per hour, or light years per whatever. Like we could be in whatever units we wanted, really. But when we're using group B, and that's what we got here is group B because we've got acceleration, then we got to make sure that we're in meters per second and meters and seconds and so on. All right, what do we got? We got a time here of 6.2 seconds. We've got a displacement of 220 meters to the north. And we've got an acceleration here of, oh wait, is that what that is? Acceleration? No, it isn't, Katie, what is it? What are you given there? What is that 160 kilometers per hour? That's the final velocity, yeah. Now, we want to convert that to meters per second, sure. But even before we do that, I want to ask you a question here. What's the initial velocity? Yeah? Does it say that? No, it doesn't say that. If it says it accelerates from rest to 160 kilometers per hour, then you can make VI equal to 0. In fact, it doesn't tell us that. So we can't make VI equal to 0. Now, it may be 0. If we solve the problem and work backwards, we may very well find that the initial velocity was 0. But we can't make that assumption. We don't know that for sure. So we can't make that assumption. We're not going to say VI is equal to 0 meters per second. We're looking for the acceleration here. Let's convert this to meters per second now. 160 kilometers per hour to meters per second. What's the conversion factor? What's the conversion factor? 160 kilometers is? Oh, okay, so how'd you get that? Okay, so there's 160,000 meters in a kilometer, and then there is 3,600 seconds in an hour. So 160,000 meters in 160 kilometers, and 3,600 seconds in an hour. What did you say we get there, Cody? 44.4? You probably want to go to 4 or 5 decimal places. If it's a final answer, okay, you can start rounding to significant digits if you're comfortable with that. If it's not a final answer, ideally we want to keep it to 100 decimal places. That's not really practical. 4 or 5 is probably good. Yep. Yeah, you could. Where'd you hear that? Where'd you hear that little shortcut? Ethan said, couldn't we always just divide by 3.6 instead of multiplying by 1,000 and divided by 3,600? Yeah, you could. Okay. The reason that I hadn't told you that, and the reason that I hadn't planned on telling you that until Physics 30, is because I think there's value in knowing how to convert something this way. Because what happens if you get some other conversion that you have to do that you've never seen before? Okay, if you simply know how to use a conversion factor like what you just did, even though that's correct, what do you do in the next situation, right? If we know how to do it, then it doesn't matter what units we have to convert, we'll be able to do it. That make sense? I won't mark it wrong. If you just divide by 3.6, I won't mark it wrong. But make sure you understand that as well. Ethan, just in case a new one comes up sometime that you've never seen before. All right, what do we got? T, D, VF, A. We know it's a group B equation. Let's say D is equal to VFT minus 1/2 AT squared. I think that's the one that I want to use here. Yeah? Oh, we want to solve for this one, for A, right? What do you get rid of first? Went through this drill on Friday, sorry. Yeah, get rid of the stuff that's not connected, that's not attached to the A. What is not attached or not connected to the A? What is it even? Good, VFT. Now, how do you get rid of the VFT? How do you take it to the other side? You're going to subtract both sides by VFT. Some people would say add, right? Why would we subtract? It's subtracted here from 1/2 AT squared, isn't it? No, it isn't. It's added. It's the 1/2 AT squared that's subtracted. Okay, you want to take the VFT over. There's a positive in front of that, right? So take it over by subtracting. It's going to look like this. D minus VF times T equals negative 1/2 AT squared. Now, looking for A still. Next rule is get rid of what is attached. What is attached? Tell me something that's attached to the A. Yep. Negative half. Good. Tell me something else that's attached to the A. Besides the negative 1/2. Yep. Okay. Sorry? T squared. You can take both of those over individually if you want, or you can take them both over at the same time. They're both multiplied by A, so we're going to take them both over by dividing, and I'm going to do it at the same time here. D minus VFT, now be really careful here, all of it divided by negative 1/2 T squared. That looks kind of ugly, doesn't it? Yes, it does. It doesn't have to be pretty. It's right. Okay? Correct isn't always pretty. Now we start plugging our numbers and see what we can get here. The displacement was 220, I think, wasn't it? Yeah. 220 minus VF was 44.44. And T was 6.2. Divide that all by negative 1/2 times T squared. Okay, let's pull out the calculator and do this one as a group here, okay? Please follow closely along on this as we do this. We're going to say 220 minus, now let's put a bracket in, because we want to put both of these together, right? The 44.44 times 6.2. We don't want to subtract 44.4. We want to subtract 44.4 times 6.2. So get the number inside the brackets, subtract that from 220. Let's press equals. I get negative 55. Now let's divide that by, what do you want to put next? What's the next keystroke that we should enter here? Nolan? What's the next keystroke that we should put in our calculator? Okay, focus here, okay? Yeah, you know what I would do even before that? Bracket. Bracket. Good, Elena. Bracket. Then negative 0.5. I'd probably just go negative 0.5 times 6.2 squared. And then, Elena? And the bracket again, right? So it gives us 2.89 seconds, which I assume is the answer in the book here. Yeah, 2.9 meters per second squared. Hey, we went 2 digits there. We're going to start talking about significant figures a little bit. This is 2 digits. This is 3 digits. This is 3 digits. The final answer should always be rounded to the least precise piece of data. And our least precise piece of data is 2 digits here. So our final answer should be 2 digits. 2.9 instead of 2.89. Make sense? Why do we round it to the least precise piece of data? Well, it's kind of like the argument, you guys have all heard this expression before, a chain is only as strong as its weakest link. Well, the weakest piece of data we have here is 2 digits. We can't be any more certain of an answer than 2 digits because there's one piece of data that we're not certain about more than 2 digits. Okay, if it went beyond 2 digits, great, we know more about it. But if we only know the first 2 digits, then the most we can know about our answer is our first 2 digits. Make sense? Okay, so always round to the least number of digits in the question. All right, I want to do one more example with you before I set you free on a couple questions. Then one more example after that that's not from your textbook, just one of my questions. It's a good challenging question for you. And then we'll be done acceleration. We'll do an activity tomorrow. Okay, and then we'll move on to something new, something different on Wednesday. Still kinematics, but still going forward a little bit on Wednesday here. Page 52 says, a bullet accelerates the length of a barrel of a gun 3/4 of a meter with a magnitude of 5.35 times 10 to the 5 meters per second squared. What's the speed? What speed does the bullet exit the barrel at? It's group A or group B? It's group B. It accelerates, right? It's not traveling at a constant speed. It's accelerating down the barrel. It's the gunpowder essentially exploding, which is causing it to accelerate, to speed up down the tube. What do you got here? What do you got here as a given? I got 0.750. I got 5.35 times 10 to the 5. And oh, look at that, I got a question mark. Somebody tell me one of those things. Yeah. Ethan? Good. First one's displacement. To the right, to the left, to the east, to the, we don't know, right? To the positive direction. Forward. Sure. Sure. How's it got another one for me? Is 5.35 times 10 to the 5. Good. We should put the units in there. What are we looking for? Yep, can we? Velocity? Yeah. We're actually looking for speed, right? Not velocity. That's okay. I can accept that, but I want you to be a little bit more specific. Not just velocity or speed, but initial, final, what? Not the change per se, although the change would be the same. You get the same answer for the change in velocity as you get for this. But technically, we're looking for the final, right? I'm going to call it final velocity, even though it's really speed we're looking for. Doesn't matter. Hey, anything else? If we read between the lines, is there something here? Yep. Oh, good, good. Doesn't come out and say that, but we know from just our own general knowledge about guns, even if we've never fired one, we know the initial velocity is 0 meters per second. What equation do you want to try here? It's a group B, right? Yep. Good. Good. Look at where you guys are coming here. Okay. A week and a half ago, you never even heard of this equation. When we first started dealing with group B equations, and that's been quite a while now, because we've been looking at them for a number of days, but even still, when we first started looking at them, you guys, there's no way you would have given me that equation right away. Okay? And some of you may still be having a little bit of trouble finding the right one right away. That's still okay. But you guys are making a lot of progress here. Okay, this is what we want to use. We want to find VF. So I'm going to say VF is equal to the square root of VI squared plus 2AD. VI is 0. I can cross that off if I want. Or I can literally put the number 0 in there. Doesn't matter. 2 times 5.35 times 10 to the 5 times D Hey, take a step back from this for a second. Look at that number for acceleration. That's a pretty high number, isn't it? Remember we said one day gravity is about 10? And you guys have heard of G-force before, right? If you experience 20 meters per second, that's about 2 Gs. Or 30 meters per second is about 3 Gs. This would be about 53,000 Gs. No, sorry, 5,300 Gs. That's a lot of Gs. Okay. It accelerates to that speed over a distance of 3/4 of a meter. When it hits you, it slows down to 0 in a much, much shorter distance. Do you think its acceleration is going to be more or less than 5.35 times 10 to the 5? More or less? Way more, because the stopping distance is a lot shorter than 0.75 meters, right? So if this is, what, 5,300 Gs, then the G-force when it hits your body is way more. That's why it hurts so much, right? Or worse. Let's calculate this on our calculator again. Let's do what's inside the square root sign first. 2 times 5.35 times 10 to the 5 times, hey, did you see what I did there with the times 10 to the something? Don't do this. Don't do 5.35 times 10 to the 5. I'll tell you what. 7 times out of 10, that'll work for you. Okay, if getting a question right 70% of the time is good for you, all right, then keep doing that. But that's not what that's meant for. Okay, when you want to do scientific notation, that's not how the people that designed your calculator intended you to do it. They intended you to do this. 5.35, and then second function, the little EE button. That's times 10 to the something. That's the way they intended you to do it, and that's what's going to get you the right answer 10 out of 10 times, not 7 out of 10 times. So 5.35 times 10 to the 5 times 2 times 0.75. Then we got to square root that. 895.8 meters per second. That is more than Mach 2, more than twice the speed of sound. In other words, think about this. Sound travels at about 340 meters per second, less than half that speed. Somebody fires a gun, okay? The person that gets shot doesn't even hear the gun, doesn't even hear the sound. Why? Because the bullet traveled from the gun to them more than twice as fast as the sound traveled from the gun to them. So, the person that gets shot, sorry? Well, if you survived it, yeah, you'd hear it after you get shot, exactly. It's like, what's that? Oh, bang. Oh, got it. Oh, that's what it was. Yeah, I thought that's what it was. That's what they say it felt like. But yeah, if you've survived it, you would hear it afterwards. Yeah, about, depends on how far away you were, but twice as long afterwards. All right, where do we round that to? Digits? Look at our data. How many digits is this? 0.750 is 3. The first 0 doesn't count. The last 0 does. That's 3 digits. This is also 3. The 10 to the whatever doesn't count either. 3 digits, 3 digits. Final answer should be 896 meters per second. 3 digits. Right? I will not take off marks on a quiz or a test right now for significant figures. I want you to start thinking about them and start trying to do them correctly. But I won't take off marks for significant figures until after your first unit test. Got it? We'll give you a chance to practice them before we start zinging you for marks for them. Okay? You ever have a question though? If you're working on a homework problem or a quiz or the first unit test and you're not sure how many digits, put up your hand, ask me. Should it be this many digits or what? Yep. All right, let's take a look at these two questions, please, on page 52. All right, let's have a look at number 1. It says a jetliner lands on a runway at 70 meters per second, reverses its engines to provide braking, and comes to a halt 29 seconds later. So 70 meters per second, what is that in kilometers per hour? That's going to be 200 and something kilometers per hour. It's moving pretty fast, right? And then you guys know if you've ever flown on an airplane, it decelerates very, very quickly. As soon as it hits the ground, that reverse engines go and they slow down, not to stop, but they slow down to a really, really slow speed really, really quickly. The runway just isn't long enough to go 200 and whatever kilometers per hour for very long. Reverses its engines, provides braking, comes to a stop 29 seconds later. What's the jet's acceleration? What's the length of the runway required to come safely to a complete stop? It's a Group B problem, right? It involves acceleration. What do we got here? Nothing red pen, okay? Nothing kilometers per hour or funny units or anything like that. So let's just write down some givens here. We know that something is 70 meters per second. We know that something is 29 seconds. We want to find the acceleration, and we want to find the displacement. Why the displacement? Well, how far does the airplane go on the runway? How far does the airplane go to stop? That's how long of a runway we need. What do we got here, Mackenzie?
Wouldn't it be negative 70 meters per second? Slow it down.
No. No, let's tell me what these are first, and then we'll answer that question a little bit more clearly, though, okay? Yep. That's the initial velocity, good, and this is, okay, good. Now, Mackenzie asked a good question a second ago. He said, wouldn't the velocity, the initial velocity, be negative 70 meters per second? Should it be? Because it's slowing down, right? No. The initial velocity is the initial velocity. It doesn't matter what happens after the initial velocity. That doesn't change the initial number, okay? Okay. You're driving down the highway. Do you have your driver's license yet, Mackenzie? Yes? What kind of car do you drive? Nissan Altima, okay. So Mackenzie's driving down the highway in his Nissan Altima, and all of a sudden a deer runs out, and he hits the deer. Okay? He's not hurt, thankfully, but his car is wrecked. Okay? So his car is no good anymore. What kind of car is it? It's still a Nissan Altima, right? It doesn't matter, like, if that's what it is, it doesn't matter what happens to it. It doesn't matter how it stops, whether it's a deer that hit it or whether it's your brakes that caused it to stop. Okay? The initial velocity is 70 meters per second. It doesn't matter how it stops or whether it speeds up or slows down. Okay, this is what it's moving. This is, this makes it the Nissan Altima, right? Now, something's going to be negative as a result of it slowing down. Can you tell me what it is that's going to be negative now, Mackenzie? Good, the acceleration. Now, we don't know what its value is yet. We're going to find that, and when we find that, that's going to tell us as well that it's negative. But we're going to make a prediction that it's going to be a negative value. Is there anything else that we have here, if we read between the lines? Yep. The F is what? Good. Comes to a stop. All right, let's say, I'm going to say D is equal to VI plus VF over 2 times T. VI is 70 plus 0 over 2 times 29. What do we get for that? 1,015. Hey, would you look at that? I just solved for B, didn't I? That wasn't what I was looking for. I was looking for A. I picked an equation, and I just happened to find B first. Is that okay? Is it okay to do B before A? Sure it is. Why not? We're going to round that, by the way, to 2 digits, which means it has to be in scientific notation, 1.0 times 10 to the 3 meters, or as they have it written out there, 1 kilometer. Okay, what's the acceleration? Maybe I want to go, let's see here. How about A is equal to delta V over delta T? Delta V is VF, 0 minus 70 over 29. That's going to work out to be negative 2.4 meters per second squared. Is that okay? Could you have used another equation? Oh, especially once you find D, sure. VF squared is equal to VI squared plus 2AD would have given you A. Okay, D is equal to VI plus VIT plus 1/2 AT squared would have given you A. Okay, lots of options here at this point. Okay, let's take a look at number 2. I don't want to do it completely, but I will address it, Ethan. Okay. Big thing here probably is the kilometers per hour, right? Okay, red pen stuff. Okay, that's going to be its initial velocity. This is going to be final velocity. This is going to be acceleration. And we want to find, what are we looking for there, Ethan? Displacement, yeah. In other words, how far does the car go? That's how long the ramp needs to be. So we got D, got A, got VI, got VF. Probably say VF squared is equal to VI squared plus 2AD and rearrange it for V. Try that. If you have trouble with it, let me know. All right, I got one more example for you to do. You're going to have to copy this one out, unfortunately, because it's not in your book. So give you a second to do that, and then we'll take a look at it as a group. Okay, let's have a look here. Last one that I'm going to go through with you today, okay? 1,600 kilogram car begins at rest at a stop sign, then accelerates at 4 meters per second squared for 5 seconds, then travels at a constant speed for 34 seconds, then slows to a stop in 8 seconds. So it speeds up, then it goes at a constant speed, and then it slows down and stops. We want to find out how far the car has traveled. What do you think here? Group A or Group B? Yep. Group B. Who says Group B? Who agrees with that? Group B. Okay. Who says Group A? Oh, a couple people say Group A. All right. Well, you're both right. You're all right. Okay, couldn't be wrong on this one because in the end, there's Group A and Group B. How can you have both in the same problem? Because we see the word then or something that means the same as the word then. When we see the word then or something that means the same thing as the word then it means we got to do something different. It's accelerating. Look, it's accelerating for 5 seconds. And then it's traveling at a constant speed. And then it's slowing down. There's 3 things here. There's really 3 problems. There's stage 1, stage 2, and stage 3, where we accelerate or use Group B. Then there's stage 2, where we're traveling at a constant velocity, where it would be stage A, and then we slow down or decelerate, where we'd make it a Group B problem again. Because it's really 3 different problems, 3 separate problems, let's write down our givens separately for all 3 of them. Question there, guys? Okay, let's not do that right now, okay? Okay. What do we get for the first one? The first of the 3 problems. Hey, it's not really, shouldn't really be harder than the other questions, right? It's just 3 times the work. Yeah. Good. It begins at rest, so VI is equal to 0 for the first problem. What else? Yep. Good, for the first problem. Somebody else this time. Yep, can we? Good, the time is 5 seconds. I don't think we have anything else for the first problem here. What about the second problem? What do we have given to us here? Not much, right? Yeah. Yeah, we got a time of 34 seconds. That looks like it's about it. What about the third one? Yeah. VF is 0. Good. Comes to a stop, right? VF is 0 meters per second. Anything else? Okay, time is 8 seconds. I think that might be it, right? Okay. So let's solve something here. Makes sense. We're probably going to start at the beginning here, right? Totus, look up here. We want to find the displacement for the whole thing. So let's find the displacement for each section. Let's do it here first. Let's say D is equal to VIT plus 1/2 AT squared. You could try any of those group B equations. Okay. In the end, if you get a displacement, it's the correct number. VI is 0, so you can just make that disappear if we want. What do we get there? 25 times 2 is 50 meters. Okay, good. Third of the way there, right? What's the displacement in stage B? Stage 2. Remember, the only equation that we can try here is this one. My group A equation. Boy, it's been a while since we've used that. I'm going to rearrange that, by the way. Take the t up by multiplying, it becomes v times t. What's v? Uh-oh. Uh-oh. Yeah. Isn't it what? 50 meters? No, that's a displacement in the first stage. But you're getting there, kind of on the right track. Yep. Good. It's the velocity at the end of the first question. So what I want to do here is go back to the first question. Even though I didn't need the final speed there, I want to go back and find it anyways. I'm going to go back and say VF squared is equal to VI squared plus 2AD, or some other equation that will get me final speed here. Okay, VI is 0. So VF becomes the square root of 2 times A times D, which is the square root of 2 times 4 times 50. I think that works out to be 20 meters per second when we do the math there. Would you look at that? The final speed for the first section is 20 meters per second. Well, if I'm speeding up 18, 19, 20, and then I go at a constant speed, what's my constant speed? What am I moving at in stage B? Okay, 20 meters a second. We got another given now. Look, the velocity in stage B is 20 meters per second. Didn't have that when we started, but now we do. So let's say 20 meters per second times a time of 34 seconds, which is going to give me 680. I think it's 680 meters. Stage 3. It's a group B problem, right? Stage 3 because we're slowing down. We got another given here, don't we, for stage 3? VI is 20 meters per second. What do I mean? Well, look, I'm at rest. I'm speeding up. 16, 17, 18, 19, 20. I travel at 20 for a little while. And then I slow down. When I begin to slow down, when I begin my third stage, my initial speed is 20 meters per second. So let's go. Got a few options here, but let's try D is equal to VI plus VF over 2 times T. It's 20 plus 0 over 2 times 8, which is 80 meters. So what's my answer? 50 meters plus 680 plus 80. The total displacement is 810, I think. What is it? Yeah. Which technically should be rounded to 2 digits. Look back to here, 2 digits. 8.1 times 10 to the 2 meters. Does that make sense to you guys? If I had given you that on a quiz just now, then you guys wouldn't have done that well on that. That's okay, right? Does it make sense to you now, though, after we've gone over it? We'll probably give you a quiz tomorrow. I won't give you a question that's quite this challenging on that quiz, okay? It'll be another acceleration problem like you had on your last quiz. But as I say, it won't be quite as bad as this one. All right? Here's what I'd like you to do right now, guys, and for the next, you got about 10 minutes left in class here. We've got some check and reflect questions on page 52. We can do all the way up to number 14. We'll make a decision at the end of class, depending upon how things are going, as to where we make the cutoff for homework tonight. I probably won't give you all 14, okay? But as I say, we'll make that decision in just a few minutes here, okay?